You're welcome to our African Research Network event. And some of us, we know that this is non-new network in which some of we have been part of. And the new website is online now. You can always check it up. And if you want your profile or you want to have a blog on the website, you can always get across to us. For those who are new to the network, it's just a network of African researchers, PhD researchers, and also scholars, lecturers, staffs, and professors, senior colleagues all over. So we started at the University of Birmingham, but is extending as membership is coming, request is coming from Canada and also the US. And on the website, you can always click to register if you have not registered. And also, you can also check up the links to all other existing networks across UK and also outside the UK. And with regards to today's webinar, it's just one among the series of webinars we've been having, and it's going to be recorded or it's being recorded. If you don't want your face to show or you don't want to be recorded as a participant, you can off your camera, but we always enjoin everyone to on their camera so that conversation can be visual as well as audio. It won't just be we're listening to the person. And this seminar is the version for December. And at the end of the seminar, we come up with a newsletter, which is sent across as a sort of publication about what the program and what each speaker represents. So their ideas, and this translated to other languages that are spoken across Africa, as a network is not just about English speaking African nations, but extended to other part of Africa. So like we had similar events with Dr. Nathaniel Bazil in August, in September with Professor Remy Olatubosun, Dr. Paul Akin Otiko, and Shegun Afolabi, Dr. Shegun Afolabi. In October, we featured Sheila Mukile and Yasmina. And last month, we had a lot of discussions on legal context and issues affecting research and scholars and immigrant context in the UK and beyond with Philip Ohami. So today we are having the session with the engineers and the people in science and all the technical disciplines. And especially we start from home, from the University of Birmingham. So today we have Dr. Hart Abarasi, Khadijat Olorunlambe, and Sagir Yusuf on board. So the host for today's event is winner and Oni, and who is a PhD student here at the University of Birmingham School of Engineering. He's actually in civil engineering specifically, and he started his second year of the program just recently, and he holds a bachelor degree in mathematics with statistics from the University of Nottingham, and is using the background in mathematics to investigate how data from geophysical survey can be better interpreted. So Winner is a Christian, is a musician, and also a member of our ARN team. So I hand over to him while he coordinates today's events as he talks and also moderate with the co-engineer. So I welcome everybody that are on board, and we hope we have a good time.
Yes, thank you very much, Augustine, for that introduction. I welcome everybody also for coming and welcome you to the meeting today. Can I just ask that if you mute your mics on so that there can be clean audio for everybody on their own devices. So if you're not speaking, please mute your mic so that there can be clean audio. Thank you very much. So welcome again, everybody, to this wonderful webinar today. We are going into the engineering department, and I'm sure we're all happy about that. So I have a few panelists today, 3 of them, as we've been as we've seen in the introduction that Augustine gave us. We have Dr. Hart here, we have Khadija, and then we also have Sagir. Now, Dr. Hart is a multidisciplinary researcher, and he graduated he holds a B engineering, a Bachelor of Engineering, and a master's degree in advanced chemical engineering, and he has a PhD in chemical engineering. And he has over 6 years of integrated professional experience spanning industry, teaching, consultancy, research, and development. And he has professional training in the oil and the gas industry, as well as in academia. Now, as a research scientist, he has worked on a broad range of heavy oil recovery and upgrading techniques, gas analysis, catalyst preparation and characterization, and hydrocracking reactions, biomass conversion technologies, and particle technology in the UK and in Nigeria. Currently, he is a research fellow with the School of Chemical Engineering at the University of Birmingham, working with a team on electromagnetically assisted catalytic upgrading of heavy oil, AKA ECHO. Now, if that is impressive, I want you to clap where you are. Also, we have Sagir here today. Sagir Yusuf Mohammed is graduated with BSc in Computer Science at the University of Gambia in Nigeria. He's currently a PhD researcher at the University of Birmingham. He is investing his time looking into mechatronics, robotics, and automation engineering. He's also an accomplished web and mobile app developer. So if you have any web development work that you have, you know who to go to, or any mobile apps that you might want to have. He is the man for you. And he has been practicing for over 7 years and has afforded, and this has afforded him great skill in many of the environments that are used to develop these things. Now, we're happy to have him here today for our webinar. And so thank you, Sagir. Thank you, Dr. Hart. And we have here in the house, Khadijat Olorunlambe is a PhD student at the Mechanical Engineering School of Mechanical Engineering. She has an enthusiasm and commitment for using engineering to solve complex medical challenges. Our current research looks at how the acoustic emission technology can be used to monitor joint degradation with potential of becoming an exciting diagnostic tool for arthritis. So anyone with any arthritic problems, she is on the way to get you some help. All right. So I welcome everyone here to the meeting once again. Each of our panelists will have 15 minutes to speak to you on their particular subjects that they have. And please listen attentively, engage. There'll be time for questions, there'll be time for discussion, and we'll be opening the floor for everyone to have a question that they might have, or speak to the panelists. First up is going to be Dr. Hart, and he'll be speaking to us for the next 15 minutes. Over to you, Dr. Hart.
Okay. Hope everyone can see my screen.
Yes.
Yes, we can.
All right. My name is Dr. Abarasi Hart, and like I've been introduced, I'll be talking on the value of waste. Waste is something that we are all familiar with, and we see daily. And this is particularly part of my research, like the part that deals with the application of heterogeneous catalysts, and the other part that deals with the biomass conversion technology. So just a brief of introduction. Normally, when we see a chemical process plant, we put in some raw materials. And when we put in some raw materials from our process, we get a product. And this product, we get to utilize this product either for some household use or packaging, as the case may be. And at the end, we throw away the waste. Alternatively, we also have materials that we can get directly from the environment. We can utilize them or consume them in the case of food, and we'll get also different kind of waste. So you can see like the various two processes we generate waste, either from our process, either from direct use of material, and at the end we have waste. So first waste I'll be talking about is shell waste. Like you have the seashells, as you can see over there, eggshells, and you have also snail shells, and you have animal bones. These are waste we normally see in our environment, and normally they are being disposed of in landfills, and that is just a waste of resources. So currently, the typical industry will always use raw materials to produce a product, and at the end we'll have a waste. But in recent time, for the sake of sustainability and also for the sake of the environment, we are now moving to use this waste material as a raw material to make other products or to generate energy, as the case may be. So one of the material I've worked with, I've had 2 publications on it, and a book chapter is eggshell and seashell, including, in fact, all this waste you're seeing here, I've worked on them. So some of the products you can get from, you can use this material for, you can use it to make absorbents that you can use to treat wastewater or purify waste gas from industrial process. You can use it to make hydroxyapatite material for tissue engineering application to make artificial bones for tissue engineering application. You can also use it as catalyst for various catalytic reactions, which I won't be going into for the sake of time. Then you can use some of these materials like the seashell to make blended cement. One of the key components for cement production is limestone. So, and these seashells have had a lot of calcium carbonate. So we can actually get the lime that is used for cement production from this material, and that we can use it for blended cement. There are a whole lot of other products we can get from them. Another waste we are common with, which is particularly a concern globally, has been plastic waste. As you can see, the plastic bottle, the polythenes, and the PVCs, these are common waste we see these days. So one of the things we do with plastic, we normally recycle them, but present recycling can only accommodate 15 to 20%. So what can we do next with this whole lot or abundant of this waste material in our environment? Typically in a Nigerian setting where these things are just lying around our environment, we can generate fuel from this plastic material by a process called thermal pyrolysis or pyrolysis, and we can generate liquid fuel from it, and we can also generate char from it, and that char is similar to normal activated carbon, which we can use for wastewater treatment as well. We can use it for energy generation. So we can use it to generate through incineration to generate steam for gas turbines, to drive our gas turbine. We can also produce some chemicals for petrochemical use from this waste plastic. And of course, we can get plastic wax, which is still under research as a suitable substitute for asphalt for road construction. So another kind of waste we see in Nigeria is sawdust. This is common waste material we see. When we use wood, we saw the wood and we produce a lot of sawdust, and at the end it ends up in landfill or just decomposed within the environment. So some of the things we can produce, we can use it to make bio oil production, which is a substitute we can use for biodiesel production or other fuels and chemicals as well. The biochar from the pyrolysis of this wood sawdust for bio oil production, we can use it as activated carbon for catalysts and also for absorbent for either gas purification or wastewater. We can also use it for hydrogen production. The world is moving towards hydrogen gas cars. So we can actually use it for biomass gasification reaction. So when we do that reaction, we can get hydrogen from it, and that hydrogen We can use it to drive hydrogen cars. We can use it to produce biogas. You know, if you ferment it, we can get biogas from it for cooking gas at home. We can use it for energy, just by just combustion of the material, and we can use it for energy. And of course, we can also use it for, let me just say, okay, pulp for paper production, of course. So this is another common waste we see in Nigeria, and the only thing we use it to do, waste tires. We just use it to roast cows and goats and stuff like that. And you know, the military men will use it to just create a fire on high street, and that action alone is polluting the environment. But what can we do with this material, and what is the process? It's just more or less shredding these tires, using magnetic separators to remove the wires and metals within, and we'll get the rubber. And we can use it for rubberized asphalt, for paving, for road construction. We can also use those shredded tires for as filters for wastewater, industrial wastewater. We can also use it to mold new rubber parts for other applications. Then, of course, we can use it as a turf for like normal field and sports field, as the case may be. So finally, I will focus on this. This is more generic in our marketplaces in Nigeria. We see food waste, a lot of it. So, and this is looking like a waste, but we can use it to make products which include normally biogas production, cooking gas. We can get it from it through the process called fermentation, or we can use a digestion process. So put some microorganisms that will digest them and release the gas, and the gas you can just use straight as a cooking gas, although it contains some carbon dioxide, which we can kind of separate, but you can use it directly as a cooking gas. And the remnant you can use as a fertilizer for agriculture. So these wastes are lying. There are other host of waste, but because the time is limited, I don't want to go in depth in terms of processes that you can use to get this product out of this waste. But these wastes are lying everywhere in our country, and they have become a good raw materials for industry and for energy production as well. So I think this brings to an end my talk today. So questions, answers?
Thank you very much for that interesting talk.
Okay.
I was really engaged with many of the things that you were saying there, all those different kinds of waste. So the time for question and answering will come in after the third speaker, the third panelist. But before I move on to the third panelist, just want to just to give you some of the questions that I might have to come up with at the end, or when question and answers come, so that you can think of that for me, because that's a question that came to my mind. Because so my main question: what are the main limitations to implementing these things, especially in an area like say in maybe many countries in Africa, or Nigeria in particular, for example, as you made mention of through your presentation. So I wanted to ask what are the main limitations to the implementations of these things, and why? What is it? Is it governance? Is it knowledge? Is it what are the factors that are affecting it? How can we combat these things, right? So that's the question I want you to have as a thinking material for yourself over the next 30 minutes when I come back with the question for the whole house. And then anyone who also asks questions on that, make sure you jot them down. Short-term memory is not really good for everybody, so you might forget in 30 minutes time. So write them somewhere, or even pop them in the chat box. All right. So my next speaker is going to be Khadijat, and she is going to be speaking to us today as our next speaker for the next 15 minutes. She's going to be talking on acoustic emissions as Biotribological Diagnostic Tool. That was not a tongue twister. I don't know why I almost struggled. Anyway, so I hand the floor to Khadijat. Please, you have the right to share your screen, and if your slides can be shared. 15 minutes. Thank you very much.
Hello everyone. Thank you for the introduction, winner. So I am Khadijat Olorunlambe and I am a PhD student here at the University of Birmingham. So my work is how something called acoustic emissions can be used as a biotribological diagnostic tool. So just before I go into the presentation, a brief explanation on what we mean by tribology. So basically tribology is just the science of friction and wear. When you have two things rubbing together, the fact that you have these two things rubbing together, they create what is called friction, which is the resistance of the movement, and that is what we call tribology. So by adding biotribology, it just simply means that tribology applied to biomedical systems applications, so the human body, implants, everything like that are what we call biotribological things. So now moving into the presentation, let me start the screen. Okay. So first, think about why artificial joints fail. So when you have your joints replaced, such as hip implants, knee implants, and spinal implants, they tend to fail because of various different reasons, like shown in this chart here. Wear is the most common reason. Then we have infection, loosening, and also some fracture. Of all those reasons, majority of them are actually tribological characteristics, which is why the idea of using acoustic emission came into play, because since majority of the reasons why artificial joints fail are tribological in nature, then it is possible for us to use the acoustic emission technique to actually try to understand why artificial joints fail. So usually to diagnose the failure of artificial joints, the current diagnostic systems are imaging techniques such as X-rays and CT scans. But the limitations with this is they can be expensive, they take time, and you also have the fact that patients are regularly exposed to radiation, which can be damaging to your heart, to your health as time goes on. So the benefits of using the acoustic emission system is that you will get a simplified diagnosis process. You feel little or no pain, and also the healthcare system can save a lot of money. Now, how does the acoustic emission work on it? So an acoustic emission system is a non-destructive test that can be used to monitor and recognize damage and progression of damages in things that would damage by making sound. So as shown in this diagram here, if you have an object that you've loaded and you put your sensor next to that load, due to the points of the load is going to cause some sort of distortion in the system, in the load, in the object, such as fraction. So that would be the source of the acoustic emission waves. And that is now picked up by the sensor, which then goes into the AE instrumentation, which is you have a system that detects and records and measures the kind of wave that has been recorded. And that will be recorded in form of this signal that we see here with the basic nomenclature, such as the amplitude, which is how high the signal is, the rise time, the time it takes for it to reach the peak period, the peak amplitude, duration, how long the signal lasts, and the count, how many times you usually go over the threshold. So it's going to record in the form of these waves. Now, the AE system itself has been used in tribological interactions in mechanical system, such as tooling, in looking at how your mechanical tools actually work. We used to look at some metal systems as well. It's now also been applied to the application of the medical body, such as looking at how the human joints, how you can look at tribological assessment. So it's been looked at to look at how differentiating between someone that has arthritis and someone that has a normal healthy knee, for example. So this has shown that there is a thing for us to actually try to use this acoustic emission to look at how artificial joints also are maintained and how they are working in the body, and maybe even diagnose how they fail as well. So the aim is to now use acoustic emission to monitor the tribological phenomenon that is in the artificial joints, and by extension, try to diagnose the failure of these artificial joints as well. So how is this going to be done? There are two processes to it. First, you have the testing as well. So we have a bench test that we're using to look at the materials, in terms of the materials used for artificial joints. So for example, you have here ultra-high molecular weight polyethylene, because you mostly have metal and polymer bearings in your artificial joints for your hip and knees. It's mostly metals and polymer. So looking at metal and polymer tests, doing tribological testing of them, we also measure the AE signals that is recorded during this tribological test using the tribometer and an AE acquisition system. So you use that to acquire the signals from the testing of these metals that would be rubbing against each other. So you have metal and polymer rubbing against each other, signifying what would happen in a human joint. Then you have the second part, is the analysis of this AE signals that you record. So there are three ways of analyzing the AE signals. You have the parameter-based technique. You look at the amplitude and you look at the root mean square. You look at the energy of the signal individually and together. You also look at the frequency-based technique. That's why you look at the frequency. So there are different things to everyone's. The frequencies are different. They have big frequencies. Each of them are significant in different ways. So you use that to look at, to sort of, to analyze the AE signals and to kind of get the information that relates to in terms of what's happening in the joint. Then the last one is to use machine learning techniques such as regression analysis, your clustering and neural network classification to actually try to differentiate our signals based on the source of the signal. So results so far, when we looked at what we call the polyethylene rubbing on a metal called cobalt chromium molybdenum metal. So that's a typical metal for a joint in the human body. Looking at, for example, the coefficient of friction curve and the root mean square curve of the AE system against time, we can see that both curves mimic each other. So the fact that both curves mimic each other is quite a good thing, because it shows that we can actually use our AE results to also explain what is happening friction-wise, because what will happen is when you want to actually look at the maintenance and the condition of your implants in your body, you can't do this friction test that we'll do on the outside of the body in the lab. We can't do that with the knee joint or the hip joint. So if we can really just put the AE sensor on the knee or the hip joint, and we can also relate the AE signal back to the friction that is happening, then we can use that to sort of determine the condition of the artificial joints. Then going further, at the points that I've marked A and B, so now I have what is called the continuous wavelet transform of the point at A. So at the point at A, we've looked at an individual AE signal and brought out the frequency analysis of that AE signal, the way it looks. So as you can see, there is a dominant frequency at around 162 kilohertz. So the broken section on the graph signifies where this test has moved from steady state, running in, to the second stage, which is the prolonged sliding. Because at the start of the test, you have when the two materials coming together, they start rubbing together, and the roughness and the asperities of the surfaces of the materials would rub together and to smoothen it out. So that's the start where you have instead the running in period. Then when it now comes into normal sliding, it goes into prolonged sliding stage. That's stage 2. So for stage A, we have a waveform that has a frequency that is dominant at 162 kilohertz. And going further at stage B, the frequency that is most dominant is now higher, 230 kilohertz. That signifies to us that we are now at a stage where there is prolonged sliding happening. And we can see that there is more oscillations of the root mean square of the AE voltage at that point as well, which signifies why you have a higher frequency there than at the beginning. So this can also help us to differentiate between stages of test, being able to signify, okay, this is the start of the test, that's towards the end. So that can be related back to also the age of your implant and how it's doing over time. And the same thing was done for, there's a second material just for comparison purposes, which is PEEK. Polyethylene ketone is also a good material that has been used in spinal implants. So it's shown to have very low coefficient of friction and good wear behavior. So comparing that as well, it has similar results to the polyethylene material rubbing on the metal as well. Here we can just see that because the PEEK is a more ductile material, it has a lot more oscillations, and we can see a lot more curves in the waves at the second part of the test. It's because the PEEK is more ductile than the polyethylene, so it's going to produce a lot more waves, and the AE signals have higher energy in this test as well. But just for the first one, at the first start during the running in, the frequency is 150 kilohertz. And during the steady state, the frequency is 230 kilohertz. So the frequency increases at the second stage of the test. Now that we actually can see how we can use our AE signal results to interpret tribological phenomena by looking at friction, for example, we can now go further to actually see that, okay, if we can use it to interpret what's happening, friction and wear related, how can we then actually signify which one is due to a different kind of wear? Because when things are going to fail, they fail due to different reasons. Even though it is wear, there are different kinds of wear that can happen. It can also be friction, it can be fracture of the implant as well. So the next stage is to actually use the machine learning techniques by, for example, starting to use clustering to look at differences between your adhesive wear and your abrasive wear. So in this test, a different test whereby a controlled test where we control the adhesive wear experiment, the abrasive wear experiments, this kind of wear was simulated and then now looked at the results to see if we can differentiate between them using the AE signals. So first using clustering, when the adhesive wear test and the abrasive wear test were both clustered, the clustering allowed us to show that actually there were two clusters which we could relate to the different stages of the test. So the running in stage and the steady states or prolonged sliding stage for both the adhesive wear and the abrasive wear test. Then for the classification parts, so a backpropagation neural network classification was used, whereby you use a supervised classification model. So the results from both the adhesive and the abrasive wear test was combined together and labeled, and they were used, and this classification model was actually trained using some of the data, and then you test on the rest of the data. And after the testing, training and testing, we found that we were able to successfully classify these results into 97% classification accuracy of the model recognizing the signals that came from abrasive wear test compared to the ones that came from adhesive wear test. 3 different classifiers were actually tested, and the one that worked the best was the BP neural network at 97%, and the K-nearest neighbor also worked well at 96%. What this has shown is that the fact is that, okay, it's giving us confidence that we can actually use the AE signals to also differentiate between the different kinds of tests. So it means that there's possibility to use it, potential to use it to differentiate between the kind of damage that's also happening during the use of the implants in the body. So to conclude, what we've found so far is that the AE root mean square curve can be used to interpret frictional processes and by extension the wear. The waveform features can allow us to distinguish between the running in and transition stages. And when we cluster it performs better than using the waveform features because it actually gives us a better understanding of distinguishing between the 2 test stages. And we can classify our signals based on the kind of wear mechanisms that has happened. So these actually show that there is a potential for AE to become a better tool to monitor the condition of artificial joints than the conventional methods that are used now. And it also has a potential to be used in the early detection and identification of suboptimal condition of artificial and natural joints. Thank you.
Thank you very much for that wonderful presentation. If you enjoyed it, clap where you are and give our speaker give our speaker a round of applause. Thank you very much for that. It was very interesting. I really enjoyed all the things that were said there. I just have a question which I mean, maybe I missed it, but it didn't quite come across to me. What were the perhaps the disadvantages of this new system, at least in comparison to the ones that are already established, the ones that we use now? I know you mentioned the disadvantages of those current ones, but are there any disadvantages to this new method or to this new technique, even if it should be, if there's a way to perfect this research and it works very well, are there some things that we should be wary of when that time comes? So that's just thinking material for you at the end of the whole process. I'm going to bring on Sagir, but before I do that, I'm going to just refresh our memory and to just tell us that, you know, our first speaker spoke to us about the value of waste, and has talked to us about the different ways in which we could convert everyday wastes, some everyday wastes, to useful things. And I just want to remind us that if we have any questions, put them in the chat box or write them somewhere, and when the time for questions come, you'd be able to ask the panelists. Of course, Khadija just spoke to us about how to develop a new technique for monitoring arthritis and or things in arthritic patients. And if you have questions on that one too, please make sure you put them in the chat box so that we can ask them and have an interesting discussion at the end of this panelist discussion. Sagir is going to be up next, and he's talking about research on robots or robotics in Africa. Sagir, over to you. I think you're muted, Sagir, so please mute that.
Hi, all. Good afternoon. My name is Sagir. I'm a PhD student at the School of Computer Science, a second-year PhD student. So I'm looking at effective coordination of multiple robots to work together using minimal resources. That is, how can we minimize the resources? Or just in summary, how can we task simple robots to perform the same project or task that can be performed now by a very complex and intelligent robot. So I'm looking at an optimization problem on how can we effectively utilize the robot's energy, battery capacity, memory, and computational capacity while we are dealing with their coordination problem. So I took a use case of surveillance, that is space exploration mission. So in this talk, first of all, I will introduce you to my research, that is the coordination of multiple robots or drones. So actually in my research, I took unmanned aerial vehicles, popularly known as drones, as my use case, and how can we effectively utilize their capacity in achieving some missions. So that's my main aim and objectives. Then we will also look at how we can apply some robots, simple robots, to solve or to address some indigenous problems in Africa. And also, because Africa is a unique continent than the others, because if we talk about robotics in America, we are just dealing on how to make money. Usually robotics in Europe is all about humanity, and also robotics in China is a bit complex. It's just having fun, developing things like that. So in Africa, we have our own specification, our own culture, our own level of development. We must think in a way that will conform or address our problems. You can't just take solutions from America, within the Europe or China, just take them directly and apply those solutions in Africa. So what are the key challenges you need to consider in deploying, whether it's robots or in general AI? So that will be the key messages of my talk. So I will first start with introducing you to my PhD research. What are my end objectives? What am I investigating, and so on. Lucky enough, my investigation also suits African application. That is, because of the level of development we have in Africa, we are a bit behind, I'm sorry to say the truth, but we must think in a way of to utilize the resources of the robots we want to apply there because of the level of development we have. So I'm actually investigating on how to achieve, don't mind the English, when we say situation awareness, actually, we are talking about how you can coordinate different information together brought by different agents. When I say agent, actually, I mean the independent robots you have, the drones, whether they are drones or leg robots or something. So we want to coordinate these drones in a decentralized manner. That means without communicating to each other, without having a central server that will be coordinating the attacks. The reason behind that, there are two key reasons for security, because if you just put robots to act together and they can communicate with one another, they can easily be hacked. We have seen lots of issues between Iran and US, unmanned aerial vehicles deployed in Iran, and was hacked by Iran agents, and brought down and received all the information. So we are just looking at how we can make that fully decentralized. That is, they will just be following some rules, but by just seeing them, it will be as if they are communicating to one another. And none of the the robots will have full understanding of what is happening in the environment. Each of the agents will just be performing its own task, so that even if one of them were captured, you can only get part of the information, which will not be usable in interpreting the current context of the environment. So also, the issue of communication. Communication is very expensive. You have to send signals, you have to pay for security and so on. So if we can actually task robots to follow some rules, some policies during their operation and conduct a mission automatically as if they are communicating with one another. So we can just be able to save all these calls for security challenges, also for communication, for power, message interpretation, and so on. So my main objectives of my research is trying to come up with a framework or architecture that will show how you can achieve that distributed situation awareness. That is how you can actually integrate the information brought by independent agents during their operation, independent robots during their operation, and be able to extract some meaningful insights from those information. So also, how can you generate some effective path planning? Because of the constraint for our communication, your robot has to follow some rules or policies, so that maybe you can task the robot just go to point A, after going to point B, go to point C. So how can you obtain these policies for multiple robots, let's say like thousands of drones, to follow some rules without communicating to one another? But by following the rules, they will conduct their mission, whether it is surveillance mission, searching mission, or patrol, or anything like that. They will just conduct the mission intelligently as they are communicating with one another. So actually, in summary, I'm trying to optimize the policies that will be controlling the robots' mission activities, such as the path planning, that is places to visit. So this is, in summary, my research objectives. When we are trying to apply robotics in Africa, I just trying to take the key areas that I think need urgent attention currently, such as the security issue. If you can see from the picture on the left, most of our military or police, they are ill-equipped and poorly trained in terms of handling simple technological robots, let's say drones. We just used to explore our military in just forests, patrolling, doing some reconnaissance missions, searching for terrorists, and so on. While but we can achieve that with a robot of less than $100. If you can buy a drone of less than $100, can quickly survey the area and brought out the information. That is the situation awareness I'm talking about. We just bring some usable information for them to just analyze, and now they are just putting their life into risks of ambush by Boko Harams or any other terrorist groups, whereby in Africa, we have this capacity. We don't have to think bigger, just like Europe or America. We just need robots of millions of dollars. No, that's why we need to focus on optimization problems in terms of application of robot to some civil areas, talk less of the military. If you can buy some drones like DJI drones, they have even ones less than $100, and just deploy them to these militaries. They can be able to sit down at their barracks while surveying the forest, whether it is Sambisa or somewhere else. Also, in terms of agriculture, agriculture is contributing a lot in the economy of Africa. So there are some advancements of, we need to apply some robot to revolutionize the way we cultivate our crops in terms of applying fertilizers to our farms, pesticides, and so on. So simple drones can just take and survey everything for you and do such tasks. And also in terms of industrialization, we have some like the robots. So person, in terms of the application of robots in Africa. So these are the selected areas, but it is not limited to only these areas. There are a lot of areas that need urgent attention, such as the economic sector and so on. But to me, these are where we have to pay more attention, because they set the basic foundation for our economy. Without security, We can't achieve anything. Without agriculture, we can't achieve anything. There will be no food. And also industrialization, there must be some way of creating jobs and so on. So once we say that we are to deploy robots to Africa, that is a unique continent. We are not talking of Europe because we are actually different from them in terms of civilization, in terms of cultural or religious diversity, and so on. So there are some key factors that we need to consider in both the engineering aspect and also the human aspect. So I try to itemize a few of them. Once you are tasked to apply some robots or some application, like some of us that are going into application development, so you will see that Africa is entirely different. You just go to class and study software engineering, but after coming to practice it in Africa, you can see that what you are facing is entirely different from what is currently on the ground. I started developing my application, one of the accepted ones, I think, year back 2013 or 14. I noticed that some of the users, I just put some help button, but most of my users cannot read or write in English or their native language, Hausa. So I just put a support button. For instance, if you want to contact me, just pop up a WhatsApp message. So they just keep calling me. I say, why are you calling me? Why are you calling me asking for caution instead of just dropping it on WhatsApp? They say, we don't know, we didn't read about it, we don't know how it's. So even chatting with them on WhatsApp, I have to record some audio. That is why I know the essence of recording voice mailing in any chatting platform. So in Africa, we have our own indigenous problems, so they have to be addressed appropriately. We can't copy from others. So in terms of human aspect, once you have to deploy some robots, for example, robots like drones for surveillance with the military, and for like agriculture, if you want to apply pesticide or fertilizers in your farms, you have to first see that you are both of the engineers, that is the engineers that will deploy the systems or the robots there, and the users of the robot. You have to know their level of education first, because you can't just compare a white American soldier with ours. They're just going to extensive or hard military activities. So their level of handling computer application is entirely different. So you have to know that this is Africa. Maybe you have to change language. Maybe you have to change some certain form of functionalities to conform to their indigenous problems. So also effective motor awareness. How can you communicate to them? This is really important. I think my father told me around 1960s when they brought fertilizers into Nigeria. So they took them to their village and packed them in cars, and they said, come and take, this will help you in terms of your farming. They said, no, this will kill our farms. So as time goes on, nowadays you have to buy the fertilizer. So you have to know how you can communicate with them and tell them this thing is really helpful. Because in Africa, we have our different passion of thinking, or mentality. You just can't carry with drone. They say, oh, this thing would just be surveying our farms or killing our farms or something like that. So you have to get the right channels to communicate, whether they are imams or pastors or something like that. This is actually helpful. And also you have to check about the diversity, because someone will ask, am I talking on art or those sociology or something like that? No, once you are trying to use a system in computer science, you have to know the types of your target users. So you have to know their cultural and religious background. For example, if you just carry a system that will just be making some noise or something like that, that is actually different from their way of thinking religiously or culturally, I think you will get some problems, more especially in terms of religion. Because I can see that some people, when we go back to history, people accepting common microphones in mosques or in churches, you have to go a lot of issues. So you have to address that, no, this is helpful, this we're going to really assist. And in terms of the engineering aspect, of course, the most important aspect is to pay attention on the resources. Are those robots available? You can't just come up with a problem that needs a robot of millions of dollars and say you will deploy it in Africa. So is there internet connection? I'm currently in Nigeria, and Augustine knows I used to have issues with internet, and I don't know whether you have seen that already. So there are some issues that you have to consider, and also the current infrastructure and the context. This robot, will it work in Africa? Is there the security for that? For example, if you just apply your robots in some of the areas, I think they can be easily attacked by bats or people just catapulting or something like that. So you have to know the context where you want to apply your robot in. And challenges regarding the successful deployment, I think these 3 key challenges are the most important challenges. One of them is the transparency issue regarding our leaders. You know, a lot of corruption. If you send a proposal, let's say for the ministry or for the military in deploying drones for their surveillance mission, the main key point to be considered by their head, I think, is what will they earn from it? What will they gain after the installation? So that's a key challenge. And also, was it a robust? I think, can it handle a lot of tasks? Can it conform to the current structure in Africa? And also, another most important task is the context awareness and reasoning. You have to know the current context, the current environment. Africa, I think, we have a lot of ethnic tribes and so on. So you have to consider all these factors and their religion, their cultural background, and in order to know what type of robot you want at a particular environment, and also the team you will construct in terms of deployment. We have a lot of mentalities about racial differences because, let's say, for instance, in Africa, we usually neglect our own product. So you have to consider your teams. We have that very bad mentality that if we see something from the whites, that's really genuine. So maybe for the sake of this period, you have to add 1 or 2 white people in your team in terms of approaching with in terms of approaching the leadership or whether the governance of the people that need some application of robots that you want to deploy. In summary, I think this key point is very important. Contextual reasoning is actually needed. That is, we have to select right technology, right AI, right robots for our own African problems. So, for example, as I said earlier, it has to be very cheap, which my research also pays attention on that. That is how to minimize their battery, their energy, remove communication, and improve some security on that. So all these algorithms and architectures need to conform to the contextual problem in Africa. Apart from the people you want to deploy to them, you will also have to consider the environment, whether it is a mountainous terrain, how your communication will be, and what are your source of power, what type of robot do you need, did they conform to their cultural or religious belief, and so on. So that's what we have to focus on, because we really need those problems in Africa, those solutions. In Africa, we have a lot of challenges. Africa is turning to terrorist ground from all indications, a lot of fighting. So we need a lot of application of robot to support the government activities and so on. So I think this is my talk. Thank you so much for listening.
Thank you very much for speaking. A lot of interesting things in that in those slides, and a lot of interesting things that you had to say. Some people are already giving their clap offering there. So thank you very much, Sagir, for that presentation. It was very informative, very enlightening, and we're very grateful that you were able to do that today. So it's time for our questions and answers and discussion period. We'll have each of our panelists answer a few questions that you have asked or And if you have any questions that you want to ask, just indicate by raising your hand using the button provided on the platform, or just put your question in the chat box, and then we would amplify that for you and have them asked on your behalf. So I'm going to go back to Dr. Hart, our first speaker for today, who spoke to us about the value of waste and how we can, the things that we can do with waste and how they are, how they can be reused as useful things within the society and within industry and even in normal day-to-day life. And Dr. Hart, at the start, I asked, well, at the end of your presentation, I asked the question, asking what you think are the main barriers, what are the main problems to the implementations or limitations to the implementations of this thing, some of the conversions of waste that you highlighted for us. And so I just wanted to know, especially in countries and regions like countries within Africa and perhaps any other area where they're struggling with this, what are the main problems, what are the main limitations that prevent such useful use of waste to occur?
Okay, thank you very much for that question. And firstly, before I give direct answer to the question, our population is increasing, and I guess the focus here is Nigeria. So as the population increases, the waste generation definitely will increase. So looking at it in terms of that, it means there should be key awareness by the government. And it is not only that awareness, but we should borrow some ideas from the system that have implemented a procedure or a protocol for collecting waste. Like as we are in the UK, we do some manual sorting at home, and the waste collectors, they come and collect this waste and they take it to a central point. One of the times when I was in Port Harcourt, one of the things they do is that they just collect the waste and take it to a dump site. I think at the dump site, the waste is just for landfill, and you can't decompose plastic that is looking like almost hundreds of years for it to decompose, which is practically almost impossible. So what are the factors limiting this? It means one of the factors is policy, government policy. The government have not actually put a policy that will drive the sorting of waste, the generation of waste, the collection of waste. And secondly, the awareness in terms of education is not there. Why did I say the awareness is not there? Aside the policy, people can normally, if they eat, buy and sell on the road, and they throw the waste on the road, or they trash it in the drainage. So you can see the mentality is still very crude. You know, the mentality is still very crude. Then secondly, the government have not made it also a priority, or community planners have not made it a priority to collect this waste. If they have made it a priority to collect this waste, as few meters at every road, we should be seeing waste bin, you know, practically meaning that the government is interested in collecting the waste because they know the value of the waste. Then the other area is that the government has not also assembled experts on, say, we are generating waste, a lot of waste. And as our population is increasing, at some point, we are going to be saturated with waste. And if we don't do something now, then at some point it's going to become a environmental nuisance. So there should be government assembling experts, technocrats. And this is where there is an agency that is called Raw Material Agency or something like that. We know that there's another agency that is in charge of, you know, it's more or less like innovation. They come up with innovative technologies. There are these two agencies are there, one for raw material, one. So it's either these two agencies are not functioning or they are not also looking into the problem. Because like I said, if you're looking for raw materials, the waste automatically becomes a raw material to produce other thing. Then if you're looking in terms of innovation, which is the other agency, then the technology to convert this waste into a useful product or for energy purposes becomes also something that is innovative. So those are the two. I can't really remember the other name, but I remember the raw material agency. So I think these government agencies are not at the forefront, are not at the forefront. Yeah.
Okay.
All right. I saw another question just now pop up.
I'm going to bring the question back to you, but I want to
okay.
bring in Khadija and Sagir. Sagir, I think he said Sagir. So sorry for mispronouncing your name. Khadija, I have a question here for you. So in your someone wants to know your in conducting this research, what tools have you been using for your quantitative analysis? What have you been using to produce those wonderful analyses that you showed to us in your graph and the conclusions you were able to make? I think you need to unmute your mic. We're missing out on some important nuggets here. All right.
So thank you for the question. What I have been using for my analysis is there is dedicated software that is for analyzing the acoustic emission signals itself. So I use that in combination with MATLAB. So I use a lot, when I don't use the software, then I do a lot of things on MATLAB. So all my graph drawings, I do them on MATLAB. I write my scripts and my clustering analysis, my classification, I do everything on MATLAB because MATLAB is very robust. So you can use MATLAB, you can use any programming skills available. You can use R as well. You can use Python as well. I just like using MATLAB because I'm comfortable with MATLAB. So I use MATLAB for almost everything.
Okay, thank you very much for that question. I'm just going to bring Sagir in with a question here that I have for someone who was listening attentively to your presentation. And he has asked, so do you think, what are the, in your line of research and the thing that you've been doing, have you had, or are there indications of cooperation from government agencies like the military? You mentioned how we can use this to improve the military in terms of surveillance and things like that. In agriculture, for example, you mentioned how we could have things like drones which just go on to do what a human being would probably do for days, and they could do it just like that without all the wasted human efforts. So what are the are there indications of support from the government or from government agencies to help to facilitate these kinds of things, or to help to drive them, to make them really become reality?
Yeah, I think there is, I can say yes, but in terms of like military, in terms of the military application, we have been receiving an attention on how to deploy the robots. But the key challenges we have in that area is the way the process is going very slow, and also the way the government are not, or let's say top military officers are not paying attention and being serious on how they put the lives of young soldiers into risks by just deploying, by just avoiding to deploy those resources. But interestingly, we had a very good support from one of the key agencies in Nigeria. They are ready to sponsor our project for their what they call QoS. So they are just conducting some survey and monitoring, some supervision and monitoring tasks on grounds, but the places now are very risky. So they need some drones to fly automatically to do that. So actually we are getting maximum cooperation from that. So in summary, I can say it depends on the leadership available in the agencies. Some of them are paying more attention, like the communication industries. But in terms of the military, I think they are not serious in terms of the deployment. We have sent some proposals since years, and we are also doing it in such a way that we analyze the security perspective on that. Because if, let's say, for instance, someone leaked the information, this is just your target in the University of Birmingham and so on. But for like, for instance, on their own, they paid some resources and collaboration with the University of Birmingham in terms of knowing how to limit the use of social media, how to get some platform. So I think the leaders have their own personal interests or what they want. They're just pursuing what they actually want and suit their personal interests. So that's the main challenge. Is we are not just doing it for the sake of the country, for the sake of the security of the citizens and so on. So
thank you very much. There's a really huge political spin to our discussion today. A lot of, even with Dr. Hart's comments as well, a lot to do with political responsibility in order to achieve this thing. I'm just going to bring Dr. Hart back again. The question I have for you from Augustine says, knowing that most African nations generate so many waste or so much waste, what can we learn from China's recycling culture, and what are the practical steps that we can make as researchers to explore, so as researchers now, to explore opportunities along this route?
Okay, the first part, the lessons from China, I think it has to be more or less just like when COVID started, the awareness was more or less, there was a part that had to do with personal hygiene, wash your hands, on also. So those are, when you do that regularly, at some point it becomes a lifestyle. And when it becomes a lifestyle, it becomes part of a culture. So if that reuse of materials, instead of throwing them away, becomes a culture, then we can practice it. So some of the things we can do to aid that, for instance, when you go to shop for shopping in the UK, you have to pay for a polythene bag. So there is a price tag. So that automatically gives you the idea that you need to reuse it, so that you don't pay for another one. So there's a kind of more tax on it. So in that case, so these are some of the things our government can introduce so people can begin to get orientation on the need to recycle some of their waste, for their own use. Having said that, in terms of practically as researchers, what we could do, recently, my undergraduate supervisors, we kind of had a talk for me to come into and give some talk in terms of Nigerian Society of Chemical Engineers, and also have some collaboration in terms of a PhD. So what I told him is, I'm more or less concerned. My research is more or less, when I look at Nigeria in terms of a context, it's more or less what is applicable now and what, not only now, but in terms of the future, what will drive the future. So we are making out 2 PhD projects that will be sometime next year. And one of them is going to be centered, 2 of them is going to be centered on waste. One of the ideas I've sold to him on one of the topics was using this waste shell material to make materials that we can use to clean gas flaring. And we just stopped at, just had a little chat on it. So these are practical steps. Now, if being here and working in the UK, where you have this equipment at your disposal, we are able to collaborate with local researchers so we can kind of do some technology transfer, some knowledge transfer. So they will be able to begin to implement this in our school system, research in a way that is applicable to the Nigerian context. So once we get that done, then people can, at an individual level, use it for even to make private businesses. For example, you can see recently some people are beginning to construct personal sewage system that automatically convert the sewage into biogas for cooking. They install it at the same time as building your sewage system in Nigeria. So you can install it automatically. So you have a waste, and the waste automatically digests and gets you a gas that you can use to cook. So people are beginning to install that. So these are research that are at the rudimentary level. So if we can collaborate with researchers in Nigeria, practically they will begin to implement some of these things at the cottage level, so that we can begin to solve this problem at the cottage level. So smaller industries led by one or two individuals. So from that range, it can blossom, where the government will begin to pick interest in what is going on in order to magnify it for a
Yes.
larger society. Yeah.
Thank you very much for that answer. I'm sure the questioner and every other person that listened to are very satisfied with that. I just wanted to bring Khadija in as well, because you've given us some insight into acoustic emissions as a means of as a diagnostic tool. And one of the things that you mentioned is that it gives a simplified diagnosis process, no pain, and it's cheap, right? So I'm thinking more from the African perspective, because I know that in many African nations, we seem to be far behind in medical equipment and in terms of the kinds of things we use, diagnostic tools and everything. You'll be surprised that some people still use this, for blood pressure thing. They use this pump, whatever. I don't know if you know what I mean, then wave and and do that. But there's this really old school one that you pump something, you press this thing, and then it gives you the blood pressure reading, however they do that. And it's so shocking that when you come here, it's just a digital device that does that for you. So my question is, how is it within possibility that this kind of thing can be realized in African nations like Nigeria to help to improve? At least since you said it's cheap, then obviously it's something that at least if it can be easily, say, developed into things that we can use in home nations like Africa, if it's cheap but also efficient, obviously.
Yes, thank you for that question. I think one of the advantages that we've actually highlighted is the fact that although the implementation at first might not be exactly cheap, because you have the system itself and then you have the softwares, because by the time you want to put the whole package together, you have the softwares that is going to go deployed into the AE acoustic emission system, because now the system is different. What you want to have is the kind of system that once the doctor actually puts the sensor on your body, on the person's knee, and you do some certain movements because the sensor, he also needs to be able to understand what the signal is telling him. So you want a system now that is going to be embedded with their classification, with the analysis as well. Because right now, for testing purposes, because it's something that has actually been used a lot in civil engineering to look at when you have your structures and your bridges and your cement, when they're cracking, that's where acoustic emission was used for. So it's in more recent years, it's now being applied to the orthopedics and the medical applications as well. So you're going to need a new kind of system, because the main system right now does not do the online classification for you. So you're going to have someone write the software to implement that into the system that records the signal as well. So in that regard, getting the first one might not be cheap, but the advantage is that because it's not something that you're going to need to be changing. Once you have it, the long-term benefits is much better, which then makes it, well, I would say it's going to be cheap on a long-term scale. And actually, it would also be portable a lot more for countries in Africa to be able to actually get access to it than if you think about an MRI machine, a CT scan. being able to get those kind of machines in Africa, in a country, if you don't have a lot of money, would be expensive. But this is going to be something that once it's been deployed in that regard, and then you might need to get a budget to get the first one, but if you get the first one in one hospital, you can keep using that one. So you don't need to have a lot, and it's not going to be something that is big to carry. So it's not going to be like bulky. So, and if it's just in one hospital or two orthopedic hospitals with the doctors that you can have access to it, and it has a more long-term use, because then over time you build the software in a way that is also going to be the online classification software, by the algorithm is going to be improving itself based on usage, based on new data. So if you make it that kind of algorithm, that kind of software, then you have a better use, you have a long-term use of it. So over time, it's going to be much cheaper than what you would need to keep maintaining the amount of electricity you need to keep maintaining your CT scans. And we all in Nigerian hospital, there's no light, then you can't take the scan. And then there's so many different things that is going to be involved. So over time, it would be useful for actually kind of African use as well, because it would be possible for African and low income countries to get access to it much faster than they would than the normal systems we use now.
I like the sound of that. Thank you very much. I like the portability word there. It just sank in. I was like, yeah, that's good. If it's portable, it's going to be good in Africa. We reach so many remote places, and you can have a lot of better health system, at least to disseminate to local people. I also like the sound that, I think you mentioned that there needs to be a software written in order for it to be. So yeah, Sagir Yusuf, you have a contract, all right? I'm going to just bring in Roland, who has something to say to Dr. Hart concerning the waste issue. So Roland, please, if you could unmute your mic and then say what you have to say, please.
Good day, everyone.
Good day.
As you might have seen, my name is Roland. I have a few issues with regards to the waste. It's a global problem. Now, when I say global, I'm referring to the continent, especially the sub-Sahara. And I think one of our big problems is that sometimes we do little more about identifying the root cause of the problems. If we say we should be talking about the governments, we all know how our governments they are. Sometimes they just sit in their offices, they're looking for what they as individuals may benefit. So if we're talking about what we can do with regards to the waste, I want to draw a little case study of what we were working on a project in Cameroon and in a small town. What we actually did was that we completely, I would say, sidelined the government authorities, because sometimes they sit in their offices and they sign these so-called policies without even knowing what they are signing, because sometimes they are not even experts in the field. I'm talking of the case of Cameroon, for example. They just sign and, they just say it's like this, and they don't even know what is out there and what it's supposed to be, maybe because they have the authority to do so. So when we went there, we understood that somewhere along the line, we may be stuck. Because if we want them to get reasoning with us what is important or what is supposed to be done, or how we can address the problem, they may not sign the policies or the policy paper. So what we did was that we actually get to the local communities. We work with the local communities. In my place, we normally have like the local rulers, like the chiefs, or maybe the quarter heads and so on, as we call it. So we get from the grassroots, trying to get them to understand exactly the problem and the need for us to be able to manage the waste. And then the first thing we did was that we first of all asked them, and a lot of people cited a lot of problems, especially with plastic bags and maybe plastic bottles and stuff. They complain and complain. Then we're like, okay, yes, we are happy that these things does not dedicate, and they're always like that. And we now see that you already identify and you know the problem of that, and that's the reason why we are here. So we had to go the way around to get them to understand us and understand the need that we have to find a solution to get rid of the problem. From then, the next thing we did was that we asked them, how could we handle the problem, or how can we get the message across to the other people or the entire community about what we plan to do? And then the leaders, the local leaders that we got them involved with, the people who communicated, and we had a kind of meetings and a lot of meetings with the community. And then we first of all try our best to tell them exactly the need even though we knew some of them already found that they had issues with some of these things, but we still try our best to get them understand the need that we have to eradicate the waste. And then the next possibility was that we not only getting them understanding the need, but to show them exactly what we have to do. So we come up with a model about the sorting of waste that we already heard in the presentation. But this time, the community were the people proposing to us how they think it could be feasible. And when we work together with them, they were now like our teachers, and we are also like their mentors in this case. So it was so easy for us. It became like a mindset that people understood that we have a green container for anything that is biodegradable. And then we have another gray container for anything that's metallic or bottle or something like that. And it became a culture on every house, on every street, everywhere. People knew the importance of what we were doing. So in this case, it was a little bit easier for us to carry the waste already sorted by the various buildings or the various people in the various streets and so on. It was a little bit easier. Though we did not reach the level of reusing the waste, but our main concern was like trying to make sure that the environment is clean and to get the waste sorted and then hand it over to the next level. So actually we are still planning and coming up with another strategy, what to do with the waste that we already gathered. But for the time being, I think it was a very giant step we took by working with the community, because even the local rulers and the mayors and stuff, at one time they were a little bit challenged, and I would say they were ashamed because they could not reverse the decision with the local people. So the local people were the one now telling them exactly how they have to live in their society and how they have to run the show. So it was no longer them coming from up with the policy, but the policy, it tends like the policy was coming from below. So what I'm trying to say here is that we should also try to consider the role of the local stakeholder right down there. I think they are the main key players we have to look into when we're talking into waste here, because even the policies that are signing up there sometimes might not be interpreted the way it's supposed to be. And if the local people don't understand the need or why we are doing what, then they will be resistant, because we are talking of change here. We already have an issue. So that's a little contribution I had to make with regards to the waste problem, because I know it's really a challenging problem. Thank you.
Thank you very much. Thank you. The other question I was going to ask Khadija, she's put a response in the in the chat. Thank you for saving time for us. Okay, I'm going to call on Uti now because she's raising her hand. She perhaps has a question. So please unmute yourself and then.
Hello, everyone. My name is Utorofon. Thank you for a very enlightening presentation. I'm not a scientist, but I'm learning a lot from the different contributions that are being made. So my question has to do with the subject of waste. And I'm particularly thrilled at the way in which most of the projects in this panel are looking at practical approaches or practical solutions that will be feasible within the African environment. Because with regards to the issue of waste, I guess mine is a question focusing on the very nature of waste itself, Dr. Abarasi. Like, what would constitute polythene waste, for example, in the Western world might differ slightly when you look at, say, Nigerian context. And I'm wondering whether that factors into your research. What I mean is, for example, you go in the US, for example, you could limit, once a person goes to the grocery store and gets something in the polythene bag, comes back, that the polythene automatically becomes waste. But in Nigeria, that same polythene bag might serve as a food packaging, material. If the woman goes to a party, for example, it might be her takeaway container. If rain falls, that same polythene material might extend as umbrella, So I'm wondering about the possibilities of reconsidering waste in this instance. And then my central question is, do you also see waste as data in your work? For example, are you also looking at ways in which your analysis of these waste products can give you more information about the inhabitants of the community, or is your work just centered on solutions to like waste conversion and all of that? Because I'm thinking about the project that I had in the Mexican border, where researchers were able to look at the waste products that immigrants who cross the border leave behind and use those materials as a way of providing data about those communities. So I'm wondering what are, aspects of using the waste products that are left behind as data that can provide further information, one, into the recycling methods feasible, and two, into the material practices of the people who are actually producing this waste. I'm wondering whether that features into your work at all. Thank you.
Okay, thank you very much for the question. My research when it comes to waste is basically I'm looking at waste for energy. I'm also looking at the final product as the case may be. Now, to answer the first question you asked, which is in terms of the African context, people can use a product after maybe consuming the content, or after using it for one stuff, they can use it for other stuff. That is like the reuse. We call it, we have recycling, reuse of material, then finally it becomes a waste. So in that case, when you look at the reuse, which is good in terms of waste management, but at the end of the shelf life of that material, it becomes automatically a waste. So when it's at that shelf life end of the material, that is when I'm looking at it. What can I do with it? Now it is no more useful. It is no more useful in the African context. If it is polythene bag, it's no more useful. Now, you talked about in the context of US, polythene bag might be different. In the generally, the waste classification is the same in all countries. Food waste is food waste. Polythene bag is polythene bag because the material of production is the same. However, I am concerned about when the shelf life of the material is of no importance again. So you've thrown it away, so it becomes a waste, or it's in the bin now. So that is where I'm concerned. And my concern for that is I want to use it for energy generation. I want to use it for making other products that can have other uses. I want to also convert it in a form which the final form, even if it becomes a waste, it can just be biodegradable and be integrated into the natural environment. Then the other part you talked about, which is good, which is not connected to what I'm doing, because that is more or less a social aspect of it, where you can, of course, we know in Nigeria, different community consume different things. So you can, from the waste you get around that community, you can actually use it to tell the kind of people they are, or when you see such waste elsewhere, in a given, even in big cities, you can actually use it to identify the kind of persons that live. Even in the UK, you can't use it. Like if I go to, if I'm working with the trash collectors in the UK and I see a lot of vegetable and some kind of thing, of course you begin to trace that this will definitely be Africans, so it's normal things that, of course, but it's not part of what I'm interested in, because I'm interested in the energy part of it. How do I use it to get energy? How do I use it to make material that I can apply for chemical processes? Like when I was looking about the share waste, I'm more concerned about using it to make catalysts, because the commercial catalysts we use are made from natural materials. So you mine these materials, and in the process of mining it, there is a lot of energy involved. There is a lot of manpower involved. But these other materials, they are just waste, so they are cheap. So if I use it, it saves you the cost of investment cost. It also saves you the energy involved in getting the natural one. Then of course, we know that every natural resource is exhaustible, but these other waste, they are inexhaustible, they are renewable, because at every point in time, like for the seashell, they will definitely grow, they will definitely reproduce. We as humans will definitely consume it, so it's renewable, so it's infinite. So if I use it to make something useful, it's sustainable, and the environment at the same time will be clean. So that is the way I'm looking at it. Then when it comes to the waste tire, like for instance, when we burn it back home, we pollute the environment the more. But when we collect it and be able to use it to make something that we can put back to use into the society, just like you said, in the case of reuse, you have a material, you've used it for the actual purpose, but now you decide to use it for somewhere else. That is reuse. So when we do it for the waste tire, each shelf life have come to an end, but we are now using it for either to pave road, either for field, either for asphalt, for pavement, or as the case may be, even for as a filter bed for wastewater. It's also good.
Thank you very much, Dr. Hart, for that very elaborate explanation to Richie's question. I think I have one more question for you from Olumide, but before then, I just want to call Hayat, who has also wants to chip in here. Please unmute your mic and.
Yeah. Okay, thank you so much for the opportunity to speak here. I really enjoyed the presentations by the panelists. I really appreciate their effort. My question is just on the issue of robotics. And maybe possibly the question will be to Sagir or anyone who has kind of knowledge about that. It's just a kind of like question or advice, because it was announced around 2018 that the Nigerian government has approved the establishment of a new agency for robotics and artificial intelligence, because the country began to work on a strategic policy blueprint to commit some resources to research in science and technology, so which was expected to take off early 2019. So my question is there any information about the implementation or like establishment of that agency? If there is, then I think this is a good starting point. The researchers can have a kind of link with the agency to like work together. Perhaps it may yield a fruitful result. So thank you so much.
Yeah, I think there is an update on that. For this next 2 to 3 weeks, I think the Minister of Communication, DG, NIDA, they commissioned the center. So, but I don't know who was the head yet, or the active head. So I think there is a little bit progress on that. They have commissioned it, was it 2 to 3 weeks ago in Abuja. So I think there's a little bit of progress on that.
Thank you.
Okay, thank you very much for that question, Hayat, and thank you for your response, Sagir. Finally, I'm just going to go to Dr. Hart, and I have a question here for you. Is there, or are there cheap means of producing biofuel from sawdust? We're currently heading to serious e-waste in Nigeria. What are the suggestions, or what are your suggestions for best possible practice? I think in 1 minute, so that we can round up because of our time.
A quick answer, yes, there is a cheap means. Normally, you can use the slow pyrolysis method. The only disadvantage with that is that you get a lot of biochar from it. And the oil, the bio oil you're going to get is about around 30%, 30-something%. So that is just quite low. But if you want to go higher than that, then you will use the fast pyrolysis, and that. But in terms of the Nigerian context, I think the slow pyrolysis will be good. But either one you choose is what is your interest. If your interest is to make more biochar, then the slow pyrolysis will be good, and it's quite cheap to implement. The other thing in terms of Nigerian context, you can just pack the sawdust, put it in an enclosed vessel, remove the air within, create a vacuum in the system, heat it up, and condense the fume that comes out. And what you have is your bio oil. Of course, you're going to get some gas. Then at the end, you just open up the vessel, take out the biochar that is left, and collect your oil for further processing.
Thank you very much for that. I think.
Okay, the other one, which is the practical steps suggestion. When you say e-waste, are you talking about? Let me get it clearer.
Let me find the
Roland, right? I think it's Roland or something. Yeah, Roland. I know I saw something. Okay,
yeah.
Lumide.
Yes, it's Olumide
Yeah, Emmanuel. Yeah. The e-waste, I don't really get it.
Okay. Perhaps it's not here to expatiate on that question.
Oh, okay.
Okay. So to round up the meeting, I know we're shooting over time a little bit. I'm just going to draw the meeting to a close by asking Sagir a final question here, and I've sent it to you privately. So what are the key issues limiting the usage of robots or stroke drones in particular in Nigeria?
Yeah, I think the key challenges or issues is lack of policies by the government. So we used to say that all the time. There are no key policies that will regulate the use of the drones. For instance, in the UK, once you want to fly a drone, you have to look for a license, go off on trainings, exams, and know what you'll do with the drones and how to handle them in order to keep the environment safe. So we don't have those policies. That is why at times if you come up with a drone and you're lucky enough seen by customs or police officers, then it will put you in trouble. You have to sort them out, give them some money and all issues like that. So that's limit also the availability of such robots or drones within the country. We know we can see some people are using it for filming and other tasks like that. Later on as well, the use of the level of education we have. We don't know, or most of our people don't know that drones can handle some of the attacks. We only see drones for filming, shooting videos and so on. So they don't know that they can also use those drones in handling their agricultural activities and so on. So I think these are the main key challenges that hinders the use of drones within the country.
Thank you very much. And to bring the whole discussion to a final close, I'm going to bring in Khadija here, and I want to ask you a very interesting question from one of our participants today. And he has asked, what has been your experience generally as an African female researcher working in the sector that you're working in? So just in a few minutes, so we can end the meeting for today. Thank you very much.
Okay, thank you. I'm not sure exactly what you mean. I mean, there isn't much to say in terms of what my experience is, because I guess in the acoustic emission part, I'm the only one in our lab that is doing it. So sort of we don't know about any other male or female that is doing it. So I'm the only one doing it in that area. But in terms of the overall area, which is the tribology part, everyone is doing it. There doesn't seem to be any disadvantage to being the female African researcher, because everyone is doing it. So I'm not really sure what the question is, to be honest, because I don't really get any feeling that I'm African, I'm female. I'm just sort of working in that area. So, and then if I need help, I can speak to anybody I want to speak to. So you don't feel left out or anything. So there's no disadvantage that I'm the female or I'm African. It's just a case of it's the area I'm working in. And by the time you start speaking to people, there are quite a lot of people, even like I've met a lecturer that is in a different university, there's also a Black guy, and he's, you know, he's a lecturer now and he's working in something to do with acoustic emissions as well. So although it's sort of like a new area, it was new to me when I started my PhD, but as you learn more about it, a lot of people doing it in different applications in different ways. So that's why I said I'm not really sure how to answer that, because there is no exactly experience to talk about. So it's just, yeah, a positive experience for me, I guess. So I don't feel any left out in any way. So that's just it. So maybe if we can expatiate more on what it means, then I can answer it better.
Oh, well,
yeah, what I just actually mean is, you know, we are talking about Africans doing research in Europe and looking at the import at home too. So I was just like, you know, working in that sector, you understand this sort of thing, what imports for people who also aspire, and how as an African working in that sector, the utilization, you know, when people break their leg in Africa, they have traditional and other means in which people deploy. That's what I meant here.
Okay. So in terms of the African aspects, I think is what I answered previously about the fact that the system itself could be possible, could be good for African countries, because then you could apply it to that and then it would be advantageous. Even things like when we say we break our legs, the way we treat, you know, a broken leg in Africa is different from the way they would treat it here. So the way we treat it over there is not always optimum. And then obviously there is the issue around the maintenance after the treatment as well. How do we make sure that those things don't come up because you don't have good physiotherapy, for example? So that's not my area in terms of the acoustic emission, in terms of trying to look at what happens in joints. That could be useful in Africa because it's portable. Then as an African doing the research, still, it's just, I guess it's good. And then other Africans can also get access to do it. I don't know much than to say that really.
thank you very much. Even your first response was good enough for me, and then Augustine had some follow-up to do to expatiate further, just as you asked. So it's good that you're finding it good in your area of research, and there's nothing casting any shade anywhere. So I'm happy to hear that. Thank you everybody for coming today. I think I'm going to draw the discussion to a close here. I know that you might still have some things that you want to say. We'll be dropping the email for the network in the chat, and you can send us some of the things that or other comments that you might have, and we'll try and add them to the newsletters. If you have questions that have not been answered, please drop us an email with that, or just put it in the chat box, and we would forward them to our relevant panelists who would answer the question for you and would try and get that to you via email or another means. I think a way to try and put our time under control is to invite less interesting panelists next time because they've caused us a lot of trouble today. But thank you very much all for coming. I'll hand over to Augustine now, who would round up for the day.
Thank you very much. We thank Dr. Hart, we thank Khadija once again, and Sagir. They are busy people, but they have spared their time, and their discussion is like we have three great giants, you know, spending a slot. So it's like if we give them each slot each, it cannot become enough self. So we thank you all for waiting to the end, and we hope that the conversation continues. Just to talk about the coming event in January, we have an issue that has been coming up, and a very controversial issue, which has made a lot of people to lose their faith in a religion that is being practiced in Africa, Christianity. So we invited traditional person, and somebody who is not in any religion, and somebody who is a Christian, to come and talk about why we have white Jesus and black devil in images. So that's in January. And then you can have a context. If you have other interesting presenters, we are scheduling event for the year. You can get across to us, as many people have been reaching out. So this is the contact. And we hope if you have not registered to be part of the network, please, if you have suggestion, and then we hope the conversation continue. Thank you once again, and see you next month. Bye.
Bye.
Thank you.
Merry Christmas to you all in advance.
Okay, and Merry Christmas and Happy New Year to everyone in advance. I think that's part of the slide. Wishing you a happy holiday in advance.
Thank you. Please look at the chat box for the email address. If you have questions or further comments, would